Perfect.
Do I look old, Bonnie?
No, you're beautiful.
Okay. Now then, I like to do this little physics thing because I have to talk loud because the audio is not very good on this. When I say physics, everybody goes, oh, physics, oh, that's so hard. It's really not. And the only thing I do with physics in this, I used to do a lot more. But the only thing I do now with physics in this class is I talk about simple machines. And the reason I do that is because that's what our bodies are. And I will talk about human bodies, and as much as possible, I will talk about some animal bodies, although it's a little bit harder to get good information on mechanical advantage and so far with horses and cows and dogs and cats, but I do it as much as I can. I had some paper towels here that I was, oh, here they are. These are my erasers. Okay. You have to get the concept here. What are simple machines? Simple machines are things that allow you to do more work with less force. Woo, marker. Better than coffee. Sorry, I've never been one of these people. Allows you to do more work with less force. Sorry. By taking that force and distributing the force over distance. The essential concept here is the greater the distance that force is distributed over, the more work you can do with less force. So the greater the distance is distributed over, the more work you can do. With less force. That's the concept behind all simple machines. Okay? Somebody give me an example of a simple machine. Huh? A lever. That's one. What are some others?
Pulley.
Huh?
Pulley.
A pulley. That's another. What are some others?
Car.
Anybody here rollerblade?
Catapult. Had to throw it in there.
Yeah, you had to throw that in. Yeah,
Wheel and axle? Oh, that's a pulley, isn't it?
yeah, that is.
Crane.
That's a
Oh, you one, I'm just saying. Like an old-fashioned washing machine thing. Ice cream maker.
She's saying the thing that makes all the, makes your clothes a little bit more dry, right? Nobody knows.
Nobody's as old as us.
Are you sure you're registered for this class? A washing machine is not a simple machine.
it's a complicated machine.
That's a complicated machine. Oh, I can't rollerblade. There's two things I cannot jump rope. I cannot rollerblade. I was at the gym recently and my trainer said, oh, let's jump rope. I said, I can't jump rope. Since I was a little child, I can't jump rope. So let's pretend that's like a bicycle, okay? It's like a bicycle wheel. Okay, you're riding your bicycle and you get to a curb. This is a K-U-R-B curb. Okay? Now, to ride your bicycle over this curb, it takes a lot of force, right? You got to be going really fast to get up over that curb, and it's bumpy, right? How do you make that easier?
Ramp. An incline.
A ramp, an incline. It's called an inclined plane. If we put a K there, we'll put a K there. It's an inclined plane. A curve, a ramp. Now we ride our bicycle, and we just go right up the curve, the inclined plane, the ramp. We use a lot less force. And we just go right up the curve. That is a simple machine. We are distributing our force over distance. Let's say this curb let's say this was a 7-inch curb. Okay, so it took us a lot of force to get up these 7 inches. Let's say this ramp is what, 18 inches? Just making up numbers. That's a much greater distance. We're distributing our force over this much larger distance. But we're able to do the same amount of work. That work is going from here to here. So we're still going from here to here, but in this case we're using a lot less force. It's a lot easier to ride up this ramp than it is to jump over that curb. And what we're doing is we're distributing our force instead of over this very short distance, of 7 inches, we're distributing it over this much larger distance of 18 inches. That is a simple machine. We are distributing our force over a distance. We are doing, in this case, the same amount of work, but with much less effort. It is much easier to ride up that ramp than it is to jump that curve. An inclined plane is a simple machine. We are distributing force over distance. We are doing work with much less effort. That's the concept, distributing force over distance. You got it? That's the idea. Okay? Another simple machine. It's messy. That's a nail. Trying to get it into that piece of wood. How do you get a nail into a piece of wood? Bang, 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 bang. You're going to get carpal tunnel. Do it enough, right? Yeah, that's why carpenters get carpal tunnel. Banging it, banging it, banging it. Oh gosh, I'm not good at doing hammers. Tremendous amount of force to bang that nail into that wood. That's a screw. This time we use a screwdriver. Do you bang it? Nope. Twist it. You're distributing your force over a distance. You're not hitting it. You're just turning it. That screw is traveling a greater distance than this nail. The nail is going straight down. The screw is traveling a great distance. It's going around and around and around and around and around. It's traveling a great distance. But is it a lot easier to get that screw into that piece of wood? You don't have to bang it. You just twist it. That's all you do. You just twist it. Okay? You're not getting carpal tunnel. You're just twisting it. That's a simple machine. A screw is a simple machine. You are distributing force over a distance. That screw is traveling a great distance compared to the nail. You are distributing your force over that distance. You are using much, much less force. You're not hitting it. That's the concept, distributing force over distance. Okay, where do you want to meet on Thursday?
Here, please. So do you tell us